Hello statistics students, my name is Jami Emigh, and this video starts our discussion on section 9.2, two population means, and they're going to be from independent samples. Requirements are: 1, we need the means to be from two independent, simple random samples, and 2, we need the sample sizes to be 30 or larger. Okay, larger than 30 and is greater than 30. Or it has to come from a population that has approximately a normal distribution. All right, if those requirements are met, then we have to address this situation: to pool or not to pool the sample variances. And that is a question that you're going to have to answer yourself. So how do you decide if you're supposed to pool or if you do not pool the sample variances? Here's how. Number 1, if sigma sub 1, that right there, you guys, is the population standard deviation from population 1, and sigma sub 2, population number 2 standard deviation, if those are not assumed equal, then we do not pool the two population sample variances. And it will say clearly in the question, do not assume that these are equal. And that's your cue to go, okay, so I do not pool the sample variances. In that situation, the degree of freedom is the smaller of the sample size for population 1, minus 1, and the smaller of the population size for population 2, minus 1. Okay, so not pooling right there. Here's the other option. If sigma sub 1 and sigma sub 2 are assumed equal. So and it'll say it once again clearly in the question, it'll say they are assumed equal or they are not assumed equal. So if we're going with are assumed equal, that means we can pool the two populations sample variances, and our degree of freedom becomes adding the two sample sizes together and then minus 2. All right, let's see if we can look through this StatCrunch reference sheet very carefully. There are a lot of details on here. Don't just glance over this. I've put a lot of information on this slide, so take your time with it. First side, two independent population means given the summary of the stats. Next column is two independent population means given the data. So based on if you're given the summary of the stats or if you're given the data, that's where you start, okay? If you're given the summary of the stats, you're going to have to make that selection between T stats and Z stats. And we know that's always based on the knowledge of sigma. We're going to open the two sample menu with summary, and the input screen is going to ask you for a few things. And then it's going to ask you if you want to pool the variance or not. Versus given the data, you'll have to choose between Z-stat and T-stat, but then you'll click on the column where the data is contained. All right. These two right here, you guys, this is based on your task. So if you're being asked to do a hypothesis test, go on this side, set up your null alternative hypothesis. And if you're being asked to construct a confidence interval, then you'll go on this side, okay? So lots of details on this slide, so keep it next to you. Okay, example A. Subjects with a red background were asked to think of creative uses for a brick. Other subjects with a blue background were given the same task. Researchers claim that blue enhances creativity. Test the claim using a 0.01 significance level. Do not assume that the population standard deviations are equal. Okay, so in our group with the red background, we had 35 members. And somehow, some way, they were given this creativity score. So they had an average score of 3.39 and standard deviation of 0.97. Members with the blue background, there were 36 of them. Creativity score looks a bit higher, 3.97. Standard deviation smaller, 0.63. All right, significance level is here. This is alpha, 0.01. And it says do not assume the population standard deviations are equal. So when it comes to the point where we are asked to pool the sample or not, we are not going to pool them. Do not assume they're equal, therefore do not pool them. Okay, first task is to test this claim. So we'll set up our null and alternative hypothesis. Notice that we have mu sub 1 compared to mu sub 2, because in 2 samples, that's what we're doing here, comparing the means of each population. The inequality right here, where did that come from? Came from the word claim that blue enhances creativity. So that word right there, enhances, means we think the population with the blue background will have the higher creativity score. So if this is all pop 1 and blue is all pop 2, okay, so this is population 1. That's the red background. And this one is population 2. We need to write the inequality in such a way that where the sub 2 is, we're saying we are representing their claim of enhances by having the inequality open closer to the 2. Okay, once our null and alternative hypothesis are set up, we will go to StatCrunch and see what this looks like. Okay, once in StatCrunch, we go to Stat. Now this question is about comparing 2 population means. So you have to choose between Z and T. If we knew the population standard deviation, then we could go with Z, but it didn't tell us anything about it. So we've got to go with T. We're working with 2 samples in Chapter 9, and we've been given a summary of the stats. Okay, first population, first sample, 35 of them, and they had a standard deviate, oops, I did it wrong already. They had a mean score, creativity score of 3.39. Sample standard deviation was 0.97, and there were 35 of them in that sample. Sample 2, second one, they had a creativity score of 3.97, standard deviation of 0.63, and a sample size, there were 36 of them. Okay, here's the pooling portion. The default was recently changed to off. Okay, that's interesting. That's a new note right here. So if you don't turn it, okay, so right now it's off, but if you click it, then it's on. So right now, unclicked, this means that it will not pool the variances. If you click it, then it will pool the variances. And for ours, it said do not assume they're equal, so we do not pool them, so don't click that. Okay, null and alternative hypothesis had it equal to 0, and then if we add mu sub 2 to the other side, we need the inequality to look like that. And show critical value, significance level was 0.01. Looks good. Let's compute. P-value, if you need it, 0.0021. Critical value, negative 2.39. Test statistic, negative 2.97. All right, let's put that back in our notes. Okay, the directions don't request us a particular method. So in that case, I usually go with the p-value method. Just a little less work, in my opinion, than drawing the graph. So we've got a p-value of, it was 0.0021, and that is less than our significance level. So we would say that p is low. That means the null must go. So we will reject the null hypothesis. Okay, it's got to go. Reject it. Script from there is there is sufficient evidence to support the claim that there is a difference, ... What was it? That there is a difference in the two population means. All right. Part B, construct a 99% confidence interval to support your hypothesis test. All right, back to StatCrunch. Okay, once back here in StatCrunch, we can just go to Options, Edit, and we go to the Perform part here. We're going to ask the program to construct a confidence interval instead. Confidence level, 0.99. Compute. And for a confidence interval, we need L limit and U limit. Those are the lower and the upper limits. Notice that they're both negative. Negative 1.0985 and so on, and negative 0.06149 and so on. All right, let's take that back to the notes. Okay, so we would write that interval in parentheses, comma separating the limits. And since they are both negative, the interval does not contain 0. The whole interval is on the negative side, doesn't contain 0. So we report that there is a difference between the two population proportions. And notice that that supports this conclusion from the hypothesis test, as it should. Okay, so that is it for 9.2, pretty short section. 9.3 is similar, but we're talking about two dependent samples this time. 9.2, they were independent. 9.3, they're going to be dependent on each other somehow. So we're going to match them up. For example, data for before and after a treatment. The data from before the treatment and the data from after the treatment, we could match those up, making them two dependent samples. Data for a husband and a wife, we can match them up that way. Requirements. Means are from matched pairs from two simple random samples. And we need the number of pairs to be greater than 30, or we need the pairs of values differences that have approximate normal distribution. Okay, differences. We've got some new notation for that word. Notation for two populations that are matched pairs. Okay, new symbols. So if you have a reference sheet of symbols, make sure you add these. Lowercase d, that is the difference between the matched pairs. For example, if we're talking, let's say a husband is 50 years old, and let's say the wife in that couple is 55 years old. So the difference between their ages would be 5 years. So that would be lowercase d equals 5. That's what that lowercase d means. It's the individual difference between a matched pair. Mu sub d, that is the mean of all of those differences. Lowercase n is still the sample size, but just be careful. It's not each individual data value. It's the number of pairs of sample data. And our degree of freedom is that number of pairs minus 1. StatCrunch for two paired population means, mu sub d. We're going to open StatCrunch and we're going to use the T-Stats program. We're going to select paired, and then we will tell the program in which column our data is contained. Then we'll ask the program to either run a hypothesis test or construct a confidence interval. And we've got a lot of notes here for you guys, a lot of details on these slides, so make sure you keep this by you and read these notes when the time comes to look at the signs, negative versus positive, lower and upper limit. If they are opposite signs and zeros between them, we report not a difference. If they are the same sign, zeros not between them, and we report there is a difference. So lots of notes here that'll help you keep this page by you. All right, let's try one. With a significance level of 0.05, test the claim that for the population of heights of presidents and their main opponents, the differences have a mean greater than 0 centimeters. That basically means that the president tended to be the taller one of the two. Okay, so we don't have a big sample size here, just 5 pairs. This person was president, and this was their main opponent's height, 189 to 170. So yeah, they were 19 centimeters taller. But then check out this matched pair, 173, 185. So the shorter person actually lost this time. Here it was the taller. Here they were the same height. And here they were 1 centimeter taller. Okay, for these ones, you guys, we have to find the individual differences. So that would be 189 minus 170, 19. 173 minus 185, negative 12. 183 minus 175 is 8. 180 minus 180 is 0. And 179 minus 178 is 1. So it is actually these values that we're now interested in, because we're going to test the claim that for a population of heights of presidents and their main opponents, here's the claim: the differences have a mean greater than 0. So these are the differences right here: the 19, the minus 12, the 8, the 0, and the 1. So let's set up our null alternative hypothesis. Mu sub d. Don't forget that sub d. This is a little typo. This should be an A or a 1. And we're saying that we're testing the claim that the differences have a mean greater than 0. So the word greater right here is what gave us this inequality. And now we will take that information and run it through StatCrunch. Okay, when you open your data in StatCrunch, make sure that your first sample is in a column like this, and the second sample is in a column right next to it, and they should be paired up. All right, then you go to Stat, T-Stats, and Paired. Tell the program where you put your first sample and where you put your second. Click on Save Differences. For this particular hypothesis test, we were testing the claim that mu sub d, the difference in the means, was greater than 0. And we'll click this so we can get that critical value. All right, looks good. We hit compute. Notice what popped up here, guys, in column 3. It's got the differences for us. That's kind of nice. We don't have to calculate that by hand. Less room for small mistakes. And then over here on the output screen, we've got p-value, critical value, and test statistic. So I'm going to use the p-value method again, 0.2819. Okay, so we'll compare that to the significance level. And it turns out for this one, p is high. If p is high, the null will fly. So that'll fly, so we're not going to reject it. We fail to reject the null hypothesis, and then we say that there is not sufficient evidence to support the claim that there is a difference in the mean of the differences. Part B wants us to construct a 95% confidence interval to support our hypothesis test. So back to StatCrunch. Once you're back, just go Options, Edit, and then change your request to confidence interval, run it, and this time we're looking for the limits, negative 10.94 and positive 17.34. Those have different signs. All right, let's write that up. Open your interval with a parenthesis, negative 10.94, comma, interval ends at 17.34. Opposite signs. That means 0 is between those two numbers. Different signs. That means the interval contains 0. We report that there is not a difference between the two population means. This supports the conclusion from the hypothesis test. All right, my name is Jami Emigh. Thank you for being here, and I will see you next time.